This is the first of a series of videos that cover the basics of the implementation. We cannot cover every line of code. There's probably 1,500 lines of Java code here. So we are only going to focus on the more difficult aspects of the code. The code is organized into a number of packages, which we will see towards the end, the organization of the packages. And it uses the adapter and singleton design patterns explicitly. And it also improves upon iterator, and it implements the facade pattern. Code safety is given some prominence here so that malicious users cannot destroy data integrity. And we also introduce some new concepts such as Lambda functions and data transfer objects. Now, let us get a sense of all the classes, just get a brief look at all the classes, and then see how we do some basic operations like adding members and adding books. I have here all the classes in the library system opened. So here is user interface. It has a number of constants that denote the operations for carrying out the business processes. So what we will not do is explain what each one of these constants mean. They are obvious, like remove hold means the command to remove a hold. And user interface contains a number of helper methods like get token, get name, get number, yes or no, etc., which can be used in many user interfaces, not exclusively for the library. And following these, we see the code for carrying out the functionality, which we will see. And here is the help method. Then let us look at the facade, which is library. Library is quite long. It has two fields for the catalog and member list. Then the catalog is created as an inner class, so is member list. So both member list and catalog are inner classes of library, and we have all these methods to provide the necessary functionality like add book, add member, issue books, etc. Then the communication between the library and user interface is achieved through a couple of classes. One is a request class. This is what is used by user interface to request the functionality to maybe do add a member or issue a book, those kinds of things. And the result of a request is sent through a result object. Both of these classes extend what is called the data transfer object, which is a very simple class actually. It contains a number of fields for storing anything and everything you want to ship between the two classes or two objects, library and user interface. So if you want to add more things, you can just simply add more of those things, and then there are getters and setters for them. And there are a couple of other interesting methods here. One is given a book, this method set book fields will go and set all the fields related to the book. Of course, it checks whether the borrower is null. If it is null, it goes and puts none in the borrower and the due date. Otherwise, it gets the corresponding fields from the book object. And you can reset all the fields by calling this method. So it sets all the fields to none. And similar to set book fields, there is a set member fields. Given a member object, it sets all the member fields. So there is nothing holy about the data fields here. You can add more, you can delete some if you think they are not required, etc. If you want to put some stuff from some other classes, you can put those also here. Then there is a class, obviously, for member. It has name, address, phone, ID, etc. And it has an interesting constructor, which we will see in a minute. But many methods like the getters and setters, the equals, hash code, etc., we will not explain at all. There is no need. Similarly, for book, we have title, author ID, borrowed by, etc. Just following the design. The constructor is obvious, and we will not worry about the getters and setters and the overrides of the object methods. Hold has the book and the member objects and the date through which this hold is valid. This class is very straightforward. There is nothing difficult about it. The only method that has some amount of difficulty is valid, whether a hold is still valid. What you do is you find out the current time and the time at which the hold is going to expire and compare them. Basically, by converting them to the number of milliseconds that elapsed since a reference time. Then we have the transaction class. It has the type of the transaction, the title, and the date of the transaction. And the interesting method here is on date, which checks whether a transaction is falling on a certain date. So you can check whether this date is equal to the date that is stored in this parameter date. So this dot date dot get calendar dot year, is that equal to the year stored in date, and so on. All right. What we will do now is look at how the code for add book is distributed. So let's look at the command to add a book. So the first place to go is actually the user interface. User interface is a singleton. So there is a private constructor and the instance method and so on. You can take a look at that. And when the user interface is started, it calls this process method, which is in a loop. So the process method is in a loop, and it gets a command from the user. And if it is not equal to exit, it looks at the command and switches based on the value in that variable. And if it is add books, it goes to the method add books. So let's find where that is. It is towards the, you have to go towards the middle of the source code. Yeah, here. So what it does is it gets the name of the book. So this can be several words separated by spaces. So it prompts for the title, the getName method prompts for the title, and whatever it gets back, which is a string with spaces possibly, that is passed to the set book title of request. Request is a singleton, and that title field of or book title field of request is set. Similarly, we get the ID and set the book ID field and get the name of the author, and we set that. And then we call the add book of the library object and pass this request dot instance. The request instance has been filled with information about the book. So that is sent. And what we get back is a result object. And we examine the result object. If it is not equal to result dot operation completed, something has gone wrong, and we print this message. I have never seen it displayed, by the way. And if everything went okay, we get the title of the book from the result and we print a message. And we are in a loop. This method, yes or no, returns true if the answer from the user for this prompt, add more books, is yes. So what we need to do now is see what happens in libraries add book. And here is the libraries add book method. Library is also a singleton, and we will not explain the code for creating a singleton. We have already covered all those things. The first thing that almost all these facade methods do when they are called, many of them, not necessarily all of them, is create a result object. And into this result object, it will put the appropriate values as it carries out the request. So what it does is it creates a new book object by looking at the request, getting the book title, author, and the book ID. And it tries to insert that into the catalog. And if it is successful, it sets the fields of result and sends back the result. Otherwise, it sets operation failed and returns the result. So a book has been created and added. So let's now see what the catalog does for insert book. So you have to go towards the beginning of the class. It's almost at the top. The catalog class is here. It implements iterable book so that it can return an iterator. And here is the collection of all the books. You can see that I'm creating a linked list of book objects. And this is a list of books. And here is where we have the insert book method. Given a book object, it adds it to that list. Books.add book. I will add book to that collection, and it returns true. That is it for add books. Now let's see how add member works. It is flowing the same way. If you go to user interface, you will see a method for adding members. So it collects the name, address, and phone information, and then calls libraries add member. And when the result comes back, it switches based on the result code. And the libraries add member is after member list. Here, it creates a result object, just like add book did, and it creates a member object by after pulling all the fields from request that are relevant for creating a member, and then it inserts the member into the members which is the member list object. Insert member is very similar to insert book. And if this is successful, it sets the result code as operation completed and sets the member fields so that the user can basically pull the member ID and inform the member what their member ID is. If this did not work, if the insertion into the member list did not work out, you set the result code to operation failed. Now, what is interesting is the member classes constructor, which is here. Given the name, address, and phone, they are stored in the fields, name, address, and phone. And then the ID field, which is string, is created by concatenating whatever is in member string, which is right now just the letter M, with ID counter, which is a static field, and that gets incremented with each member creation.